Alright, so the best example from the worksheet that I've got on the website, I'll post a link on this video. So you would have to pretty much look at example 7, I guess that's the best example, the skyrocket fired vertically into the air. Alright, so if you look at example 7. They're saying a skyrocket was fired vertically into the air, whooshka, alright, and then at a height of 28 it explodes, alright, and then from there at 28 meters it explodes and projects at an angle of 60 degrees, so boom, there's your 60 degrees, alright, and it's going somewhere like that, alright. Okay, now if it explodes and with a velocity of 30 meters, so your velocity, alright, so you would write your 30 meters per second in there as well. Alright, so it says take g equals 10 meters per second squared. Okay, so here it is. We've got something that's, like, as I said, elevated. Alright, you will get questions like that where it's elevated. And question 1 will say, it'll ask you how long will it take to fall on the ground? In other words, you're trying to find the time it takes this projectile to land at y equals 0. Okay, wherever that may be. And let's see here, you've got, see, this is the diagram that you should have, and then the initial conditions, as I said. Very important that you write these. So what do we got? Initial conditions means at t equals 0. Well, your x starts at 0 once again, and your y is now starting at 28 meters above the ground. Alright? And your x dot is always going to be v cos theta. Alright, v cos theta. What's your v cos theta in this case? It is 30 cos 60 degrees. Cos 60, you guys should figure it out. Well, not figure it out, you guys should know by now cos 60 is half, which gives you 15. Okay, and your y dot is your v sine theta, which is 30 times sine 60 degrees. That's root 3 on 2. That's 15 root 3. Alright, so there are your initial conditions. I don't think I've left anything out. In order for you to find out how long to hit the ground, pretty much this question is asking you, find t when y equals 0. Alright, so from here, I'm really only interested in the y, okay, but I guess it wouldn't be too bad to do both anyway, but for now we'll do both equations anyway. Okay, so the x, quickly, the x dot always starting at 0. Your x dot is then going to be whatever you ended up with there, 15. Okay, I'm not going to go through the whole process because it'll take, this is what I should be writing in an exam. Okay, equals 0 dt equals c. Using initial conditions, like these, we have x dot equals 15. And then you got your x equals the integral of 15 dt, which equals 15t plus c. X equals 0, y equals, t equals 0, x equals 0, therefore, x equals 15t. Okay, so that's pretty simple. And then you've got your y equations. Y dot equals, here it gives you 10 as g, so start off as minus 10, and you'll get your y dot equals minus 10t plus c, right, because you integrated that. And your y dot here, right, is going to be at t equals 0, y dot equals 15 root 3. So using initial conditions, you get c equals 15 root 3. Plug that in. y dot equals minus 10t plus 15 root 3. Integrating one more time will give you minus 5t squared plus 15 root 3 t plus c. And use t equals 0, y equals 0. Once again, your initial conditions from up here. Uh-oh, my bad. Not y equals 0, guys. Y equals 28. Alright, using those initial conditions. And you'll get, therefore, y equals minus 5t squared plus 15 root 3 t plus 28. Alright, so you've got your x equals 15t, 15 times time, and you've got your y as that sort of quadratic function in time. Alright. Alright, to find the time when y equals 0, we are solving that quadratic in t. Alright, so we've got written the equation we've just derived up there. 0 equals minus 5t squared plus 15 root 3t plus 28. And that's just a quadratic in your t's. Okay, so you could try and factorize. It doesn't look like it's going to be a nice factorization, so I suggest you go straight to the quadratic formula we got in Year 10, which is going to be minus b plus or minus the square root of b squared minus 4ac. And most calculators, you're going to be able to put that in no problem. All over 2a, of course. 2a. Alright, chuck that in there somewhere. Now you're going to get two answers, right? You're going to probably get a minus answer, because back there it does equal 0 as well. And you're going to get the proper answer here. So the minus answer you can disregard. I believe it's, I don't even know, but from memory I think the time that you would get here is equal to 6.11 seconds. Something along those lines. Okay, now to then the part 2, right? It says how far from the launching site will it land. So from this launching site, this is your launching site, right? How far will it land? That's what it's asking. How far is that x? So for part 2, we've already figured out that it's going to take 6.11 seconds from there to there, right? And we've got the x displacement formula already. So, you know, x equals 15 times the time. So x just equals 15 times the t value that we found here, which is about 6.11. And 15 times 6.11 will give you 91.65 meters. Something like that. Okay. Alright, now, so they're pretty elementary questions. Then we go on to something like part 3, right? At what velocity will it strike the ground to the nearest whole number? Right, so here we got 1 is 6.11 seconds, 2 as about 92 meters, so I'll accept that. Now they want the velocity at which it strikes the ground. So going back to my previous, what I said previously, alright, so the whole thing, it's going to be 92 meters, around-ish. Cool. Alright, now they want to know the velocity it's striking the ground. Okay. And to do this one, what velocity? Right. Strike the ground. Alright. To do this one, we would need our x dot and y dot formulas. So I am sorry I didn't write it down, but if you rewind back, we would have found that your x dot was something like, I think it was just 15. Yeah, just pretty much just differentiate what you got there, right? And you've got your y dot equal to minus 10t plus 15 root 3. That's what we would have had. Okay. So in order to get velocity, remember we use velocity squared equals x dot squared plus y dot squared. Okay. And you square that. Don't forget now, your y dot at t equals 6.11, because that's where we're interested in. Okay. We'll just calculate that. Your y dot actually gives you, what's that, 61.1, 15 root 3 plus, minus 61.1. We'll get something like minus 35.119 or something, blah blah blah. Alright, and you get your x equals 15. Square them and add them. So square it plus 225, 15 squared. Okay, so that equals around 1458.36 blah blah blah. And then square root that. Therefore you get some v equals, I'm just going to go to no decimal places, okay? Nearest whole number. So that's how you find the velocity. You need the x velocity and the y velocity, and you're using Pythagoras, as mentioned before, to figure out that the velocity it's coming down at is around 38 meters per second. Alright, and lastly, at what acute angle will it make with the ground on impact? Answer to the nearest degree. Alright, so after part 3, just going to rub that out. At what angle will it hit the ground? So what they're doing is pretty much saying, hey, it's hitting here, calculate that angle, alright, that alpha angle. Alright, so in order to do that, as if you recall, I would have said something like theta equals the inverse tan of y dot on x dot. Okay, that would have been in your notes somewhere. Alright, and so in order to do that, that would equal the inverse tan of whatever we got before. Damn, I wish I wrote it down. Alright, it would have been, I know x dot is 15. What was your y dot? Y dot would have been minus 10t, so it was minus 61.1 plus 15 root 3, which gave you something like minus 35.119, blah blah. I'm just going to put that over 15 and shift 10 it to get something like minus 66 degrees 52. Okay, now remember it's a calculator. It's actually giving you this angle here. This angle here on a calculator will come out as a minus. So obviously that angle is the same as that angle. So just get rid of that minus and you'll be done. Alright. And that's how you would find the time it takes for it to get to the ground, how far it flies, and the velocity and the angle it actually comes and hits the ground at. Okay, so let's try another harder example.